let's discuss improvisational testing. So salvage substitution is probably one of the most common things that we do. So say we have two oxygen concentrators, neither one of which puts out adequate oxygen. Say they're both 30% O2. But in the case of oxygen concentrator 1, it has a newer sieve, fewer hours, but a broken four-way valve. In the case of concentrator 2, it's got a high hours, an old sieve, and a working four-way valve. Now, the idea of salvage substitution is to take two broken units and make one working unit. So we have two ways to do this. We could take the working four-way valve out of OxCon 2 and put it into OxCon 1, which has the broken four-way valve. Or we can take the newer sieve out of OxCon 1 and replace the old sieve in OxCon 2 with a working four-way valve. You really have to decide which is the higher risk and more involved substitution, and go for the one that's easier. But when you're done with this substitution, you still have to check the oxygen, the flow rate, and every other performance parameter to make sure that you have achieved an oxygen level that's above 90%. Now let's look at a second improvisation. This is the one we were just talking about. We have a high dust environment, say, or high dust or high smoke. In any ways, it is an environment that is likely to contaminate the zeolite much more quickly. So we could do two things. We could use a higher pore per inch filter, meaning smaller pores, that's thicker to trap more dust and more particulates. That generally will only catch the gross particles, which would otherwise be caught by the HEPA filter. If we use an activated carbon filter, that can actually absorb smoke, soot, hydrocarbons, and much smaller contaminants that could get through the HEPA filter, and instead, contaminate the zeolite. So, how do we test this? I think we have to look at how this influences the oxygen. So we'll talk about that in a minute.